Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 7.8, the final lesson in chapter 7. This is entitled Factoring Polynomials Completely. We've already done a lot of factoring. We've actually used factoring to solve equations, but what about factoring completely? We've got one more method we're going to teach you. It's called factoring by grouping. This idea of factoring completely, that's pretty straightforward, and the real life stuff, we'll save that for in class. So let's get started. Factoring by grouping. How do we solve by a factor by grouping? Okay, so this is something new, and this is what we're going to use to do a lot of the four-term polynomials, such as this one. Okay, so the idea here is we're going to split this into two separate binomials, and typically it's going to be the first two, and then we're going to add to that. Okay, so it's always going to be an adding, so you have to watch your signs in here, like this. And now the idea here is that we're going to factor out a common factor from each of these. So for example, in x cubed plus 3x squared, our common factor is x squared. And that's going to leave x plus 3. In the 2x plus 6 binomial, the common factor is 2. And that will also leave x plus 3. So we write our final factorization as these two, x squared plus 2 times the common factor of x plus 3. That's these two things. What happened to this thing? Is this. Okay. So it's the two outside factors added together, multiplied by the common factor of x plus 3. That's factoring by grouping. Let's take a look at the second example here. X squared plus y plus x plus xy. Okay, so in this one I can see that the x squared and the y have no common factors. The x and xy do have one common factor. You could rearrange this, but we don't need to. Let's just go ahead and split this up because I want to show you something else with this one. For x squared and y, the common factor would just be a 1. For x and xy, the common factor is an x, and that will leave 1 plus y. Okay, so I don't have this common factor here. See, I don't have a common factor here and here. So this one isn't going to work for us. So what we have to do is rewrite this so we'll put the y's together. So I'm going to say x squared plus x, which are these two, plus y plus xy. Now that's these two. So now I can do that. So now my common factor for x squared and x is x, and that's going to leave x plus 1. For y and xy, the common factor is y, and that's going to leave 1 plus x, which is the same. These are actually the same. So my factorization here will be x plus y, that's these things, times x plus 1. There you go. That's factoring by grouping. Here's a little summary of what we're going to do when we talk about factoring completely. First, factor out greatest common factor, right? And for 3x squared plus 6x is 3x times x plus 2. Then look for your perfect squares. Look for your difference of squares or perfect square trinomial. In other words, you're kind of like shortcuts. See if there's a shortcut. That's what we call these shortcuts, or special products, right? Our special products. Look to see if you have one of these things, and then if you do, go ahead and factor that. If it's a trinomial, you're going to factor that, either simple or complex, depending on what you're left with. And then finally, if it's not finally, but actually this last step should kind of go at the beginning. Well, it doesn't matter actually. If it has 4 terms, you're going to do it by grouping, and then I'm going to add a step 5 here. I'm going to say factor completely. And what do I mean by this? When you factor a trinomial or any 4-term polynomial, you get these binomials, right? You get these binomials. You have to check and see if these binomials are the difference of squares. If you have a difference of squares here, you have to keep factoring. All right, so keep factoring, factor completely any difference, did I spell it right, of squares. Okay, always look to see if you have difference of squares. Okay, let's take a look at these two. 3x cubed plus 6x squared minus 18x, my first example. GCF first, GCF. What do I have? 3x, right? That'll leave x squared plus 2x minus 6. Then, simple factorable, x and x. I need a pair of numbers that multiply to equal -6, but add to equal +2. And that's going to be, it's going to be done is what it is, right? I can't factor anymore. So that one's done. I can't factor anymore. That's just almost just like a GCF problem. Let's take a look at the second one here. So I have a binomial, and the GCF is going to be 7x squared. So that's going to leave me x squared minus 4. Okay, and then this is a difference of 2 squares. So that means this is going to factor using our special products into x plus 2, x minus 2. Now you got to keep checking, but none of these are a difference of squares. This is a difference. X, these are not squares, so this one is done. That took 2 steps. Okay, so GCF first, and then factor whatever is left. Either it's a special case, or it's simple factorable trinomial, complex trinomial, or it could be a 4-term polynomial. Here's an example of an equation. Now we've done equations before, and this is only like one step away from what we had before. So again, we have to set one side equal to 0. So I'm going to subtract 10x from both sides. Then I'm going to factor out a common factor, which would be 2x in this case. So 2x. That's going to leave x squared plus 4x minus 5. And then I'm going to factor, this is simple factorable, x and x. I need a pair of numbers that multiply to equal -5 but add to equal 4. So that would be +5 and -1. So then I have to use the zero product property, x equals 0, x plus 5 equals 0, and x minus 1 equals 0. Okay, so x equals -5 and x equals +1. So 1, 2, 3 solutions. And again, that trinomial there basically tells us how many solutions we should be looking for. Okay. And that's it. That completes 7.8 video, and we will see you in class. We have a few more things to go over from this lesson, but that's the basic parts of it. Everything in this lesson is a summation of everything in the last half of the chapter. Okay, so thanks a lot and have a great rest of your day. I'll see you in class. Bye-bye.